Hi students, good morning, good afternoon, good evening. This is Syed sir. So today we learn about differentiation. So in calculus, differentiation is one of its part, and it is used as a mathematical tool in physics. So very important for all of us to understand the essence of this differentiation and the methods and the rules of differentiation. So maybe it is not introduced in a 8th, 9th and 10th, but it is essential and important in a first plus one. So let's start with differentiation. So here calculus is the main chapter. In calculus we have the differentiation. So the first thing is here we are going to discuss how and what is the concept of differentiation here. Let's assume you have a y and x and you have a straight line. So here we are representing y with respect to x. So this straight line indicates that there is a constant increase, and if somebody wants to know what is the slope, that is constant. Why it is constant? See, if you are trying to know what is the angle at every instant you can find the angle is constant. So here let's assume the angle is 45, here also 45, here also 45. So slope is nothing but tan theta, sin theta by cos theta. So how we can find slope, we'll discuss in this topic only. But here the slope is nothing but how much it is lean to the horizontal, that is nothing but slope. So the angle made by the inclined plane with respect to horizontal indicates the slope. So this angle theta indicates a slope for us. Okay, but in straight line, that is in a straight slope, we find the slope is constant, that is nothing but tan theta is equal to sin theta by cos theta is equals to constant. This is one case. In the next case, let's assume we have a incline, that is curved incline here. Now to know the slope we must draw the tangent. If you draw a tangent, it is as same here. If you want to know the slope, you must draw the tangent here. Tangent, we already know, the line which touch the circle or anything at one point and it is not going to intersect it. If it is not intersecting, then that is tangent. So let's assume here it is touching the curve and the angle theta is, let's assume it is 40 degree. Now theta 1, 2, you can see clearly the curve is not straight, it is curve. So the angle, the slope is continuously changing. In theta 1 and theta 2, you can see clearly the slope is not same. Then I can say theta 1 is not equals to theta 2. Then the slope is variable, that is tan theta is equals to variable, right? If I want to know what is the slope at every point, then I should find and choose a particular method. So we understood why the slope is not constant and same in both the cases. Note it down. Okay, now I'm going to erase it. Okay, now we'll find with a formula. If I want to know, it is y and this is x. If I want to know what is tan theta in this, cos theta. And one more method is there. Let's assume we have one point here and one point here, 2 points. Here x1, y1, x2, y2. See, this is x1. The distance from here to there is x1, and the distance from here to there it is x2. Now the height is, it is y1, and the height from here to there is y2, right? If I want to know what is tan theta here, tan theta is nothing but opposite side by adjacent side. If this is the angle, then I can write it as y2 minus y1. See, to know what is this much distance, only I want to know this much distance. Then if I subtract this one from this total y2, I can get, that is y2 minus y1 by, if I want to know what is the distance of this area, then if I subtract x1 from x2, I can get this one. Yes, obviously. So x2 minus x1 is equals to, I can write clearly, tan theta is equals to y2 minus y1 by x2 minus x1. So by using this formula, we can easily find out the slope of a given graph. Here the y is representing with respect to x, and someone is asking you to find out the slope. They are asking you to find out the slope. The slope formula is tan theta is equals to opposite side by adjacent side. So opposite side, if I want to know only this much portion, I don't want complete from here to there, I want from here to here only. If I subtract y1 this much from this total, I can get this one. Yes, obviously. So y2 minus y1, that is opposite side, by adjacent side. Adjacent side here, if I subtract x1 from this total distance from x2, yes, x2 minus x1. So the slope is tan theta is equals to y2 minus y1 by x2 minus x1. But don't forget one thing, the given graph is straight line. You can see clearly it is continuously equal and equally increasing, which means the slope is constant. It is not varying at any instant. It is not varying at any instant. You can see clearly it is straight line, in sense it is constant. So in straight line it is constant, straight incline. For any given graph, if it is straight, then the slope is constant. Don't forget one thing, in the figure the hypotenuse must and should be straight, then only we can find a slope. If the case B, this is case A, let me change my marker. Okay, in case B, you can see clearly we have one more case where the graph is curve. It is y and this is x. Okay, very simple. Now they are asking us to find out okay, we'll take proper graph, proper curved line. Okay, to find out the slope of any given graph by using this method, we must use and we must see that the hypotenuse should and must straight, but the hypotenuse is not straight here in this graph. Why? The graph, the line itself, the curve itself, it is curved. If you draw See, at 2 points, the hypotenuse is intersecting the curved line, which means if this line is intersecting graph at 2 points, which means it is not tangent. If something intersect, then that is not tangent. Okay, if it is not tangent, then what is the method? So we'll find alternating method to find the slope of this graph. What is that? Same. Now I'm asking you to take a very short distance, which here x tends to 0, y tends to 0. What I'm asking you, height and breadth is very small. Why we are choosing very small? Because even the earth, to understand this, let's understand with the earth itself. This is the earth, just like a spherical. So it is curved at every point, but if we observe with our naked eyes, we see that the earth is flat. If the earth is flat, then how it is spherical? There is a small logic here. If you zoom the surface of earth, at one instant, the place where your eyes can reach on the ground, that feels it is flat, which is approximately 10 to 20 kilometers. After that you can't able to see, or 50 kilometers. After 50 kilometers you may not able to see on the ground, even though you are on the mountain clearly, because we have fog and all. But while you're standing on the ground, if you're trying to observe, you can see max 50 kilometers with a high difficulty, or else 10 kilometer only. When you see this 10 kilometers, you can find clearly the earth is flat. If the earth is flat, then how it is spherical? So we have very small distance, which tends to 0, which is equals to 0. If you compare 10 kilometers with the perimeter of earth, it is negligible almost. Yes, now you understood. Now let's assume the perimeter of earth is some 1000 kilometers, 7000, whatever it is, and we can able to observe straight 10 kilometers. For some 1000 kilometers, 10 kilometers is almost point, negligible. So if you zoom any circle, at one instant it feels it's a flat one. Here also we are using the same case. The best example is earth or your house itself. You can see the house is flat. Even though it is on the earth, it is flat because you are observing a very short length. Here also we are doing the very short length, such that the hypotenuse feels it is straight. Now this chart we call as dx dy. Change in x direction tends to 0, change in y direction tends to 0. So if you draw a circle, it feels like it is straight. Now you can find out how. If you want to know the slope at any point, if you do the same procedure, change in a small change in x direction by a small change in y direction. A small, very small. If I mention here very small, that is good. A very small change in y direction. So if I want to know the slope, that equal to tan theta, that equal to y2 minus y1 by x2 minus x1 is equals to, I can take dy by dx. This is called differentiation. So if something is difficult to understand or something is difficult to measure for a lengthy one, we divide those things in a such a way that it tends to 0. It's very, very small that we feel it is 0. So that small changes with respect to x. So if you want to pronounce or read this one, the y, the change in y, I can write the change in y with respect to x. A small change, if you add here a small change in y with respect to x. So this small changes indicates or help us to find out easily the slope of this given curve. At any instant you can find the what is the slope of this curve. So this is called differentiation. Note it down. Okay, so this I can write the change in y with respect to x, or I can write in one more, in one another way, the rate of change in y or the y with respect to x. So we have so many ways to express, but you choose the most convenient and terminological way. So once again I am explaining you how and why we are using two different methods here. See, if in case the given graph is straight line, then easily you can employ the method which is nothing but tan theta is equals to sin theta by cos theta. So sin theta is nothing but what? Opposite side by hypotenuse, and cos theta is nothing but adjacent side by hypotenuse. So hypotenuse get cancelled, and finally we can see opposite side by adjacent side. So opposite side is nothing but the change in y, that is what the difference between y2 minus y2 and y1. So if I want to know this much portion, definitely I should subtract y1 from y2. If I want to know only this much portion, definitely from this huge portion, if I remove this portion, then I can get x2. So by using this method we can find out the slope. But one thing, in the straight line you can find the slope is constant. But if in case it is in curve, so in curve if you want to find the slope, the hypotenuse must and should straight, and you must draw a tangent. And you are trying, if you are trying to draw a tangent on a curved path or a curved line, it is not possible, and it intersect the curve at two different places, which is not suggestible. So to avoid such thing, we are trying to use a very specific rule, or very important and very precise rule, which help us to find out the slope. What is that precise rule? That is nothing but I choose a very small length such that change in length tends to 0, very small. Change in y tends to 0, very, very small, which is near to 0, but it is not 0. Don't forget one thing, it is not 0 but very close to 0. So if I find that, I can take hypotenuse straight line. The best example we have discussed, earth. Even though the earth is curved, at one point where you are standing it looks like flat. So if you zoom the curved line, at every instant you can find those lines are straight, and the combination of those straight lines we can consider as curved. Okay, now if you are trying to find the slope, that is tan theta is equals to y2 minus y1 by x2 minus x1. Same as the change in y and change in x is tends to 0, very small. How we can represent it? This is the symbols. So this is the terminology we are using here. Very small change in y, change in x. Or if you want to read it, the rate of change of y with respect to s. This is what we can do. Note it down. Pause and note it down. Okay? Okay. So we'll do some examples. We'll take y is equals to 5. Then find dy by dx. See, y is a constant. Yes or no? It's not variable. The value of phi is nothing but its constant value. So if you draw a graph, you can see x and y. Let's assume this is 5. So with respect to x, at every instant, wherever you are trying to find the slope, this is what the slope. Wherever you are trying to find the slope, you can find it is 0. Slope is 0. Why it is 0? You can see it is parallel to the horizontal. If something is parallel to the horizontal, its slope is 0. So this is constant quantity. Always if you are trying to find dy by dx of any constant, it is 0. So you can write dy by dx is equals to 0. So what is y value? You substitute 5 by dx is equals to 0. Got it? So why it is 0 we have discussed here. The value 5 is constant. It's not increasing, neither it is increasing or nor decreasing with respect to x. So that's why it is 0. Okay. And before we start to discuss anything, we must know what are those formulas of differentiation. Then we'll discuss about the examples. The first one is integration. Y is equals to, let's assume y is equals to x to the power of n. Then dy by dx is equals to, we can write d of x to the power of n by dx is equals to, here the power will take as coefficient, that is nothing but multiplication. In multiplication n, x as it is, n as it is minus 1. In power we are going to subtract minus 1. This is standard one, standard formula in differentiation. And next, if you want to know trigonometric functions, then the first one is sin x dx is equals to cos x. Next, cos x dx is equal to minus sin x. Next, tan x dx is equals to, you can see, minus secant square x, secant square x. Next, why I am using integration? This is differentiation, sorry. Sin x dx is equals to cos x. d of cos x dx minus sin x. Next, d of cos x here, tan x dx is equals to, we can see, secant square x. Next, d of cot x dx is equals to minus cosecant square x. Now it reverses. Now d of secant x by dx is equals to secant x tan x. Next, d of cosecant x by dx is equals to minus cosecant x cot x. So these are very important and essential formulas which help you to solve the problems. Now you just memorize this, and how to memorize I will say the technique. Let's feel sine opposite is cos. If you take cos, opposite to sine. So here we are adding negative. Tan we are getting secant. Cot we are getting cosecant. So secant is in relation with what? Tan. So along with secant we are adding tan. Cosecant in relation with what? Cot. So negative cosecant plus into cot x. So these are the formulas. Among this one is very, very important. Note it down. Okay, now we'll discuss few examples. Pause it and note it down. 1, 2, 3. Okay, now based on those formulas we'll discuss few examples. So the first example we discussed y is equals to 5, then dy by dx, nothing but d of 5 by dx is equals to 0. So any constant, if you differentiate with constant, definitely you will get the value 0. The next example is, we'll take x square. Okay, y is equals to x square. Y is equals to x square. Then dy by dx is equals to, I can write d of x square by dx. And we know the formula. What is formula? X to the n into, if x to the power of n, then n into x to the power of n minus 1. Same we are going to implement here. 2 in place of n, what we have? 2. So x as it is, and in place of n 2 minus 1. Then 2x I can write. Power 1 we can add, that means we can write, but writing 1 or not, it is not going to change anything. Okay, now y is equals to 1 by root x. Now how to find this? Dy by dx, then d x to the power of minus 1 by 2 I can write. How? 1 by root x is nothing but 1 by x to the power of 1 by 2. This 1 by 2 I can write minus. So x to the power of 1 minus 2. So this is how we can write. Okay, by dx. So what I can write? Same by using this formula. Y is equals to, so minus 1 by 2, x to the power of minus 1 by 2, minus 1. So I can write minus 1 by 2, x to the power of minus 1, minus 2 by 2. That equal to minus 1 by 2, x to the power of minus 3 by 2. So this is the answer. Now you understood how we got. Note it down. Okay, we'll take one more example. Anything, there is no fixed thing that you have to take this one only. No, we can take anything. So let's take a y is equals to 3x cube plus 2x plus 5. Now they are asking us to find what is its value. Then dy 3x cube plus 2x plus 5 by dx. Then 3x cube, take separate 3x cube by dx plus d of 2x plus dx plus d of 5 by dx. Now see, n, in place of n what we have? 3. 3 into 3, x to the power of 3 minus 1. Yes, by using this formula, in the place of n we took 3 here. It is 3. Okay. Always don't forget one thing, while you are solving this differentiation, you must write like this. 3 you must take out if it is constant with multiplication of variable. This is variables x. Then take constant outside, d of x cube by dx. So here also 2 into d of 2x by dx. Here if you differentiate with a constant you will get a 0. Now I'll write here. Now 3 into, by using this formula, 3 x to the power of 3 minus 1 plus 2 into, is there anything? Yes, 1 into x to the power of 2 minus 1 plus 0, this 0. So 9x square plus 2x, that's it. 2 into 1, 2, x to the power of 2 minus 1, 1. If you write the 1 on x to the power or not, it's not going to change anything. So this is how we solve for a given questions. So note it down. Okay, now we'll discuss few more examples which gives you a clear picture of this differentiation. So actually this is a mathematical tool to solve the physics problems. Without this we may not solve. Okay, what if y is equals to x? We use the formula x to the power of n, then n into x to the power of n minus 1. This is the formula actually. Implement or use the same formula. dx by dx is equals to x power of how much it is? 1. So in place of 1 or n we are substituting 1 into x to the power of 1 minus 1. So 1 into x to the power of 0. Then what we can get? X 1 into x to the power of 0, that is nothing but one. A to the power of 0, 1. M to the power of 0, 1. Whatever it is 0, if it is mentioned 0, then it is 1. Not. So dx by dx is equals to 1. Okay. Then one more case we have. Let's assume y is equals to 8 by x. Okay. Now, so this one I can write 8 into 1 by x. Okay. Then 8 into x to the power of minus 1 I can write this one as. Okay. Now use y is equals to 8x to the power of minus 1. So dy by dx is equals to dy in y place 8x minus 1 by dx is equals to, as we have going to implement this formula, always take constant outside of differentiation. 8 into d of x to the power of minus 1 by dx. Then 8 into, by using the same formula, in place of n is equals to here minus 1. Now substitute same, into minus 1 x to the power of, what we have, minus 1 minus 1 minus 1, this one. So minus 8 x to the power of minus 2. Yes, minus 8 x to the power of minus 2. This is the answer. Now we understood. Okay, note it down. After that we have some special cases. In this we will discuss. Okay, now note it down. 1, 2, 3, 4. Okay. Let's assume they gave you y is equals to e to the power of x. Then for this particular one, dy by dx is equals to d to the power of ex by dx. Will give the same answer again, e to the power of x. So this is constant, that means this is fixed value, so memorize this. Next case, y is equals to, he is given log e to the power of x. Now find out dy by dx is equals to d log e to the power of x by dx, that equal to 1 by x. These are constant values and formulas. We must memorize this. So these are the thing. And the next one, let's assume a to the power of 4. Then how we should write? Or a to the power of x. So first you note it down. Then we will go for the next one. Or a to the power of x we can write. Whatever it is, a to the power of x. Our wish. First we will take this one, then we will explain this one. Okay, a to the power of x is equals to dy by dx is equal to d a to the power of x by dx. Then the value is a to the power of x, then log e power a. Then you can go like this. Note it down. Okay. Okay. For example, they gave a to the power of 4. Then as we have discussed in the previous video, I took the example. Then how we should write? If a to the power of x, then a to the power of x log e power a. Use the same formula. In place of a as it is, e to the power of 4. Then next log e to the power of 4. X it is. A. Okay. See, if you see this, you can say one thing clearly. We must focus on formulas. This is the formula. Now I choose same 4 to the power of x. Now what I can write by using the formula? In place of a, what we have? 4. Okay. In place of x, we have x log e. In place of a, we have 4. You can take 8, whatever it is. Let's take here 8. 8, 8. Our wish. So same. These are constant things which we can implement directly. Okay. Now we are going to discuss a very interesting topic. What is that? Just you focus. Let's assume somebody asks you to find y is equals to sine theta dy by dx. What is the value of dy by dx? It is 0. How? Sir, just now you discussed that dy by dx is equals to cos x. Now you are saying 0. Yes. Why? See, here we are using the variable that is theta, and we are differentiating with respect to x. Theta and x are two different variables. Theta and x are two different variables. So we can't differentiate each other. Why? With respect to x, it feels it is constant. Yes or no? As x is variable, it is for other variable, it feels this is constant. Theta is constant. Yes, obviously. So if we differentiate constant with respect to x, it is 0. So let's assume somebody asked you 2t square, find dy by dx. Then d 2t square by dx is equals to 0. Why? Because here t and x are two different variables. So if x and t are two different variables, then x feels this is constant. If you differentiate with respect to x, if something constant you are differentiating with respect to x, the value is 0, as we have discussed in the first y is equals to 5 example. So then what is the solution for this? We must take what and what with respect to we are differentiating. Let's take the first example, this one. Y is equals to sine theta, and then he will ask to find dy by d theta. Then we can find the answer. Next, y is equals to 2t square, and he is asking us to dy by dt with respect to t. T are same variables. Now we can fix. So what? 2 into 2t, that is 4t. So like this we can easily find out. But don't forget one thing, with respect to one variable we can't differentiate another variable. For the second variable, the first variable seems like it feels like constant. So somebody asks you sine theta y is equals to, then find dy by dr. Waste, you can't find out. It is nothing but 0. So while you are explaining the two given variables, student must, now you can see here dy 2t square by dt. Here this t and this t are same variables. So while you are differentiating, you must focus and keep one point in your mind, that while you are differentiating, the given 2 points must and should be same variables. Otherwise we can't do it or convert it into same variables anyway, but ultimately the result should be like this. Note it down. Okay, now we will take one example. Y is equals to x cube plus e to the power of x. I'll take x power 5. X power 5 plus e to the power of x plus log e to the power of x plus sin x plus something cot x. Okay, now differentiate. Dy by dx is equals to dy x to the power of 5 plus e to the power of x plus log e to the power of x plus sin x plus cot x by dx. Now do one thing, always give separate dx. So here dx to the power of 5 by dx plus d e to the power of x by dx plus d log e to the power of x by dx plus d sin x by dx plus d cot x by dx. So now, as we know by using the formula n into x to the power of n minus 1. So 5x 5 minus 1 for this one plus e to the power of x, directly we can write e to the power of x plus log e to the power of x by, we can take 1 by x plus sin x cos x and cot x minus cosecant square x minus cosec square x. Now I can write 5x to the power of 4 plus e to the power of x plus 1 by x plus cos x minus cosecant square x. So this is the answer. Note it down. Okay, note it down. Pause and note it down. So again I am explaining you x5, we are giving separate dx, and according to the formula for this we know n x to the power of n minus 1, and if it is ex then directly ex, if it is log ex by dx then 1 by x plus sin x is nothing but cos x, then cot x is nothing but minus cosecant square x. Okay, pause and note it down. 1 2 3 4. One more example we'll take. Y is equals to, I take x to the power of, okay, 1 by root x plus 5 power of x plus secant x. Now do it. Dy by dx, this one I can write d x to the power of minus 1 by 2 by dx, I can write like this. Yes, obviously. Plus this one, a to the power of x is equals to, we know already, a to the power of x log e power a. Same formula you have implement here. So 5 to the power of x here. So 5x log e to the power of 5 plus secant. Okay, directly formula d 5x 5 to the power of x. Okay, now minus 1 by 2 x minus 1 by 2 minus 1 plus 5x is nothing but applying the same 5x log e 5 plus secant x we know already. What is secant x? Tan x. Yes, then we can write minus 1 by 2 x to the power of minus 3 by 2 plus 5x log e to the power of 5 plus secant x tan x. How we got this? We know in formulas it is there. Secant x by, secant x is nothing but secant x by tan x, secant x into tan x. Note it down. Okay, now we are going to discuss a very new concept. If in case something is given in another form with two variables, let's assume y you have x sin x or x cube sin x, or we can take anything, x 5 cos x or anything. If there are two variables are given in the given quantity, then how to solve? To solve this, we use UV method. In sense, this is u and this is v. We'll take x as u and sin x as v. For that, dy by dx, we can take one time, y is nothing but uv by dx, then we feel one time u as constant and differentiate dy by dx plus u v will feel one time constant and du by dx. By using this method, we can find out the given formulas, the given concept. So we'll implement these three formulas and find out what is the value. The first one we'll take dx sin x by dx. By using this one, here u as x and v as sin x. So x I'll take constant for the first one, and d sin x by dx plus, now sin x it is constant, v by dx. Sorry, it is x. Okay, now x as it is, d by dx of sin x is nothing but cos x plus sin x as it is, and dx by dx is nothing but 1. So x cos x plus sin x. This is how we can solve. Ready? Yes, d sin x by cos x, sin x as it is, dx by dx is nothing but 1. Okay, note it down. Okay, the next one, I'm going to pass 1, 2, 3, 4. Okay, then what about that? We'll take this one, y is equals to, or we'll take that one, x to the power of 5 cos x. So y is equals to x to the power of 5 cos x. Then d x to the power of 5 cos x by dx. We must know how to solve. Then take x to the power of 5 as u, x to the power of 5 u into d cos x by dx plus cos x one time constant, d x to the power of 5 by dx, x to the power of 5, then cos x is nothing but minus sin x plus cos x 5 into x to the power of 5 minus 1. Then can I write minus x to the power of 5 sin x plus, I can write 5x to the power of 4, 5x to the power of 4 cos x. Yes, so this is the answer. Cos x is nothing but minus sin x. Note it down. Okay, so pause it and note it down. 1, 2, 3, 4, 5. Okay, now we know UV method. Now we are going to know U by V method. What is U by V method? So let's assume y is equals to x cube plus 1 by x square. It feels like U by V. So U by V formula, d u by v by dx is equals to, take v as square, then the v as constant, v as constant, du by dx minus 1 time u as constant, then dv by dx. So this formula is permanent, and this is the formula to solve this kind of questions. X cube. Now take, now here v is equals to x square, u is equals to x cube plus 1. Wherever you see u and v, substitute the given formulas. So v is nothing but x square whole square. Only v is x square, then again square we have, so x square. So next v is x square, then d, what is u? X cube plus 1 by dx minus 1 time u as constant, x cube plus 1 d, what is v? X square by dx. Now x square, then how we can write? 3x square plus 0, this one, minus 3 x cube plus 1 and x square and x to the power of n minus 1 by using that formula. Here we can write, so this one is completely multiplying with zero minus x cube plus 1 x cube plus 1 into 2x by x to the power of 4. Now you solve this, you will get the answer. So this is how we should solve the problem. Okay, so now we are going to take one more example, simple example, because those which are difficult for you. So in this example, just you solve that, you will get the answer, that's it. So next, let's take y is equals to sin x by x. So we know the formula, u dv by dx minus v du by dx by v square. By using the same formula here, d sin x by x dx is equals to, by what we can, x whole square, then we'll take sin x as u, sorry, here u, then one time u and one time v. So first we'll take v only. Okay, so next v is x. Now d of sin x by dx minus u as sin x d x by dx. Now x square x into d by dx of sin x cos x minus sin x into 1. So I can write x square x cos x minus sin x. So this is the formula. So we have another rule called chain rule and all, we'll discuss. So we have a few more rules in differentiation, maximum minimum rule and chain rule. Those rules we will discuss in the next video, as it is going to be lengthy. Thank you. Keep studying and copy this. Pause and copy.